So the second example, the goodness of fit, it's the other example that's in the notes. It's the U.S. Census and the households in Montana. And I'm going to go through this one with the conditions, the null, the alternate, and again, go through the process on the calculator so you can see how I'm getting my test statistic and how I'm getting my p-value using the calculator. I do want you to go back, maybe look at how I use the chart one more time and see if you have questions on that. Just so you become a little more familiar with the chi-square distribution. On our work, you're going to be able to use the calculator function. Okay, so the example we're looking at, okay, one job of the U.S. Census is to find the type of households. Type of households are living where, and in this one, it's not saying that each household type is equal like it did in the colorblind example. The colorblind example had each category being equal. For this example, you're going to have to calculate the expected value a little differently. Okay, so before we even get to that, I'm actually jumping ahead of myself. Let's look at the conditions. Let's look at the null and alternate. Again, there's no parameter to define, but the conditions you can go through. So the conditions here, okay, we have counts. Yes, there are counts. These are showing the observed values here. There's 102 that are married with children, 112 married without children, and so on. Random, okay? It does say somewhere in here, community that was randomly selected. That's probably as close as we're going to get to having a random sample here. So we're good with that. And number 3, all expected values are greater than 5. We actually don't know that yet. So this is one where you have to show the expected values to justify that condition is done. So that should be somewhere in your work. And we'll get to how you get those expected values in a second. Okay, so right now let's just assume all 3 conditions are met. Okay, and we actually looking at it, you can kind of see with these numbers, they're large enough that most likely our expected values are going to all be above 5. You just have to be careful if you have a very small percentage. In this case, we have our percentages over here. So let's move on here. We have our null and alternate. The population fits the predicted distribution for household type. Our alternative is the population does not fit the predicted distribution for household types. Okay, so we're saying that at least one of those categories does not fit. And again, you can look at it, maybe predict which one won't fit or which one's making it not going to fit, but we're not going to jump to conclusions. We're going to do the statistical test to justify if one does not fit or not, or at least one does not fit. Now, instead of it being equal, this time around, it gave us our percentages. We think that for these communities, 26% will be married with children, 29% married without children, 9% are single, 25% is a one-person household, and 11% other roommates, siblings, some other form of household that we have. Notice that it adds up to 100%, so we're looking at the whole here, but you can't just add up our total and divide by 4 to get our expected values. What you're going to do this time is take your total and you're going to multiply the total by each percentage. That's how we're going to get our expected values. So the total in this case is 411. So you would take 411 times 26%, 411 times 29%, and so on, and that would be your list of expected values. That does need to be on your paper somewhere to justify the third condition. All expected values are greater than 5. Now I'm going to do this right on my calculator. So I'm going to go over to the calculator now. I'm going to go to Stat, Edit. I still have my list in from our last example. So real quick, I'm going to clear out the list. I'm going to plug in my observed values, 102, 112, 33, 96, and 68. So there's my observed values, the expected values. Again, I'm going to clear this out. And now, the calculator is going to do this work for us. I know my total is 411, so you actually can do the math right here in the work. I know it has to be the total times the percentage for that category. 411 times 0.26, and there it's giving me my 106.86 for my expected value. 411 times 0.29, 411 times 0.09, 411 times 0.25, and 411 times 0.11. I'm just going to check my work real quick, make sure the numbers are plugged in correctly. Okay, and there's your expected value. So if you just copy those on your paper, list them as expected values, and we can see all of them are above 5, so we are good to go. All the conditions are met. So there's my observed in L1, my expected in L2. To get my test statistic, I am quitting out of here, and I'm going to show the formula. It's second stat. Go over to math, and it's the sum, parentheses, L1 minus L2 squared divided by L2, close parentheses, and there's my test statistic, 13.017. It should be my test statistic. So if we're going back now to the problem, make sure you are writing down your expected values, label your test statistics somewhere on the paper, and now we're going to find our p-value. So to get our p-value, I'm going to go to the distribution. The chi-square distribution is number 8, so I'm going to go down to the 8. Okay, our test statistic was 13.017. Our upper value, there's my obnoxious big number, so we're good there. The degrees of freedom. Degrees of freedom was uppercase N minus 1. The number of categories minus 1. There were 5 categories, so 5 minus 1 is 4. And I'm pasting. So there it is. If you have one of the older calculators, it should be the lower limit, upper limit, and degrees of freedom. Hit enter. And there's our p-value, 0.01119. If you're just around to 0.011, I'd be happy with that. And with that p-value, you're going to come up with the same conclusion as we did before. Okay, these hypothesis tests, they go the same over and over again. Since our p-value of 0.011, which is less than, that should say then our alpha level of 0.05, we would reject the null. There's evidence to support the alternative. There is significant evidence to support the claim that households in Montana do not fit the predicted distribution. Okay, so that would be all I need. Okay, now again, we are not going to come out and say which one is causing this, our cause in Montana not to fit the predicted distribution. We will get more into that. We do know at least one is not fitting it, but when we get into the residual, we'll do more calculations later. So hopefully this example helped you with the steps of what you need to do to calculate and to run a hypothesis test for the chi-square distribution, the goodness of fit test.